Hello there. This is the video recording for the assignment 1 for unit ECE2191. I'll start this off by running a code and by typing in my student ID. Okay, run part 5. So the main concept behind this part, it is my output and the graph for two of my answers. Yeah. And two graphs here. One graph I use using the lecture code from lecture notes, and the other one I use it by creating manually. So the main concept is that we just need to get the data from the train set and then using this data and just find the values, just find the sum using the sum function. And then just dividing by the total number of patients by getting a length of the train.id. Okay. And also the same concept for all of these questions. Yeah, train.pwave is equal to 1, you just get the values. And for here, we just use a mean and variance built-in function. And for here, this is just the code that I use for the we got from the lecture notes and this one. And starting from here, I first get the lower and upper quartile and get a bin. From there, we use linspace to get the bin values. And from here, we find the probability. This is first for pre-allocation for efficiency purpose. And from here, just get the bin values. Yeah, in this range. And that's about it. Just here, I use this function to plot the diagram using normalization and probability built-in keyword. And this is my answer that I got. And this is the graph that I got for AF, given that the subject is AF and given the subject is normal. That's all. And from here, I just interact with the data again. And from here also, this is conditional probability. I use the conditional probability, so we just interact with the data. Yeah, and that's about it. And use the mean and variance function, get data. And then same goes for here, but you need to take into account that train.axis must be equal to 0. Yeah, and from here also the same. The only thing we add is exactly the same as question 5.5, just add the train.axis equal to 0, this part here. And for here, question 6.6 is also the same. Just add, just change this value equal to 1, and that's about it. Just use a for loop, and then from here we can plot the graph. Right, that's exactly the same. So now question 7.1. So this is the value that I got for question part 7 from here under here. Yeah, so the main concept I used is base rule. And from here, I got the values from question 5.1, 5.3, 6.1, and also basically just use the question from part 5 and part 6 to get our value. So this is the formula that I derived for each of question. I written the formula there that I derived, and this occurs for the same for question 7.1 until 7.4. Here is just I just verify my answer. As you can see, it's correct based on the verified answer. And moving on to question 7.6, this is from here we need to get the values of question 7.1 until 7.4 to get our conclusion. So yeah, conclusion is that it's written here already. So conclusion is that if there's no P wave, so the probability of having normal will be low. So you will likely have AF. If there's a P wave condition, probability of having normal condition will be higher. So yeah, from here we just derive, and the formula here is gotten from the video released by Dr. Fei. Yeah, and for part A, it's exactly the same concept. This is the answer that I got. And accuracy, sensitivity, and specificity. Yeah, the value. Basically, I just look through each of the values, and also I use base rule here. Yeah, base theorem. Yeah, to get a value. Yeah, so basically just use back the old values. It's the same for question 8.2 as well. And to find accuracy and specificity and sensitivity, we just need to, here's my conclusion that I've made. And from here, I just compare between the two values. So between 8.1 and 8.2 in order to calculate Fn, Tn, true positive and false positive. From here, I just use the old formula. Yeah, from question 7. So I run this section now. Question 9. This is the values that I've gotten from here, here, and here. Question 9.4 and the accuracy, sensitivity, and specificity that I gotten. So from here, just use it's exactly the same. Just use base rule, total probability theorem, and condition. Also assumption that I made is that it is assumed to be conditional independence. Yeah. So from here, just get the probability. Yeah, and occurs for the same for these 4 questions. Yeah, from here, just get the accuracy. But here we need to compare between two values, between question 9.1 and 9.3, and question 9.2 and 9.4. So this is when P wave is present and P wave is absent. So just compare between the values. And the same formula used. Okay, so for the part 10, so from 3 models, I found that the P-wave prediction model, the P-wave and SDR prediction model is the best since it has the highest accuracy and highest specificity, but it also has a high sensitivity. Yeah, but it's not the highest. So, and from here, I made my prediction conclusion, which is this is the best model to use. And from here, I learned that I managed to connect the probability concepts that I learned in lecture and tutorials such as Bayes' theorem and apply them to practical real-world data and come out with meaningful results. Besides that, I also increased my knowledge in utilizing MATLAB to interact with data in order to solve a problem by coming up with a conclusion. So that's about it. Thank you.